Alright, I'm gonna attempt to solve this Leetcode problem, 274 H-Index. So I'll read the description. Give an array of integer citations, where each value is the number of citations a researcher received for their ith paper. Return the researcher's H-Index. The H-Index is defined as the maximum value of H, such that the given researcher has published at least H papers that have each been cited at least H times. Interesting. Seems like an interesting metric if it's actually used in real life, which I assume it is because it has a Wikipedia link. So, alright, so let's take a look at an example. So in this case, looks like paper 0 has 3 citations, paper 1 has 0 citations, paper 2 has 6 citations. Let me index these. And then paper 3 has 1 citation, paper 4 has 5 citations. Some maximum value of H that the given researcher has published at least H papers that have each been cited at least H times. So, for example, papers 0, papers 0, 2, 3, and 4 have all been cited at least once, at least 3 citations. Papers 0, 2, and 4, at least 5 citations. Papers 4, 2, and 4, and then at least 6 citations. Only paper 2, I guess I'll add in 0 in there. All of them, so 0, 1, 2. So the maximum value of H Alright, let's read this explanation. 30615 means the researcher has 5 papers in total, and each of them had received, that many citations respectively. Since the researcher has 3 papers with at least 3 citations. Okay, I see. So this count here is important. 4, 5. So 3 papers with at least 3 citations. Versus here, there's only 2 papers with at least 5 citations, so that's less. Because that would be 2. And here there's 4 papers, but they don't all have at least 4 citations. So these we can kind of throw out or strike through, because they don't fit the criteria. Whereas these ones do fit the criteria, so we kind of just have to find that that sweet spot, that middle point. All right. I think I understand. Let's just look at this example real quick. So he has 3 papers with at least 1 citation. That doesn't cut it. I guess, though, you could technically say that you could only take one of these papers and say they have at least 1 citation. So instead of striking through it, it really just brings this to the floor. Zero papers to 1 paper, 3 papers, and then I guess this would also go to the floor. It would only be 2 papers that have at least 5 citations, and 1. So you take the minimum of this value and that value to get the H-index, I guess. So this might be a pretty straightforward computation problem. I guess the question would be how we do it efficiently. So approaches, what would the naive approach be? We would want to iterate over all the citation counts, and that would be values in list, count the number of other papers with the same or higher citation counts. And then we would get this number of papers that have at least that number of citations. And then just floor or take the minimum of that citation count and the paper count to get a potential H-max, and then find max H-max. But that would be bad runtime. That would be O(n) squared, because you would essentially have to iterate through at every iteration, you would have to iterate through it again to find the other papers with the same or higher citation counts. So I think we can do better than that. Let's look at our example again, this time trying to solve the problem algorithmically. So 30615. All right, we could sort it because the actual number of the paper we're referring to doesn't really matter. So let's just try to see if sorting it reveals anything. 3, 5, 6. This does reveal something. It reveals that everything past that is at a same or higher citation count. So we wouldn't need to make a second pass. We could just use the length minus our current index, and that would be O(n). So that'd be the best we can get. It actually wouldn't be O(n) overall though, because of the sort would be in log n. But I think that can work. I think that's fine. So let's do citations.sort. Then do for I in range 0 length of citations. Alright, so citation count is citations at our not 0 at our current value, and then paper count would be length of citations minus our current index. That's right. And then the minimum paper count would be our H. We want to find our max H, so that would be, for now, we'll just call it 0. H greater than max H, and max H equals H, and then we're going to return max H at the end. Let's try running this in our 2 examples and see what happens. Okay, for the 2 examples it's accepted. Let's try submitting it. Accepted. Nice. Runtime 0 milliseconds. Wow, that's pretty amazing. Didn't even run at all. All right, thank you for watching.